The next book is Classical Electromagnetism by Gerald Franklin. And it is like a standard introduction to electromagnetism. So we start with foundation of electrostatics, further developments of electrostatics. We go on to methods of solution in electrostatics, spherical and cylindrical coordinates, Green's functions, electrostatics in matter, magnetostatics, then magnetization and ferromagnetism, time-varying fields, Maxwell's equations, electromagnetic plane waves, electromagnetic waves in matter, wave guides in cavities, electromagnetic radiation and scattering, special relativity all toward the end, electrodynamics of moving bodies, and then classical EM in a quantum world. And that's basically just a usual introduction to electromagnetism, maybe from a more advanced point of view, mathematically more mature than usual, but still, it's pretty standard. Like usual, it does special relativity only towards the end, which I don't like. I think special relativity should be in the forefront of electromagnetism. But aside from that, the book looks pretty good, pretty decent. He uses some pretty annoying notation for tensors, which he calls dyads, which I'm not very fond of. I wish he would just use tensors to begin with. And because the dyad is, equally hard to understand than a tensor. So yeah. And it's the more modern point of view. Pretty nice book, pretty good book. He also has solved problems in classical electromagnetism by, of course, the same author. So these are basically all the solutions of his problems solved in depth. So yeah. If you're looking for a book with solved problems, this is definitely a good one then. Then we get Dunford and Schwartz, Linear Operators Part 1, General Theory. So this is a book on functional analysis and quite general functional analysis. So we start with some preliminary concepts, then 3 basic principles of linear analysis, uniform boundedness, interior mapping theorem, and the Hahn-Banach theorem, integration and set functions, special spaces, convex sets and weak topologies, operators and their adjoints, general spectral theory and applications. So that's part 1, pretty hefty book. Pretty old book, as you can see from the notation, and it's pretty hard going. The exercises are, I see here's already an exercise that we have to establish the existence of continuous real function of a real variable, assuming that it is differentiable nowhere. So these are already pretty hard exercises if you haven't seen them before. Definitely should not be your first book on a topic, maybe not even your second book, because it looks kind of hard. But it does contain a lot of really good stuff, a lot of very general stuff. It's more like a very advanced resource with some very advanced stuff in it. Next we have here The Calculus of Variations by Bruce Van Brunt. A very rigorous book on calculus of variations. So we start with introduction, some introductory principles, Brechis-de-Crone problem, Hamilton's principle, Diderot's problem. Then we get to first variation, some generalizations. Then we get to isoparametric problems, applications to eigenvalue problems, holonomic and non-holonomic constraints, problems with variable endpoints, the Hamiltonian formalism, Noether's theorem, the second variation, and some appendices. So it's just pretty good book, pretty rigorous book though, if you're not really into rigorous mathematics and proofs and everything and just want to use these things, then this might not be the book for you, but still. It's It's good for the mathematical side. If you're only used to the physical side and want to get used to the mathematics, then yeah, you might enjoy this book a lot. Definitely the #1 book I would recommend to get used to the mathematics of this stuff. Next we have here Energy, the Subtle Concept, Discovery of the Feynman Blocks from Leibniz to Einstein by Jennifer Coopersmith. So it's basically a book on the history of the energy concept. So it starts with the quest for perpetually acting machines, vis viva, the first block of energy, heat in the 17th century, heat in the 18th century, discovery of latent and specific heats, 101 years of mechanics, Newton to Lagrange to Daniel Bernoulli, A Tale of Two Countries, the rise of the steam engine and the caloric theory of heat, Rumford, Davy and Young, Naked Heat, the gas laws and the specific heats of gases, two contrasting characters, Fourier and Herapath, Sadi Carnot, Hamilton and Green, the mechanical equivalent of heat, Mayer, Joule and Watterson, Faraday and Helmholtz, the third laws of thermodynamics, Thomson, a forward look, impossible things, and then conclusion, what is energy? So it's basically a history of the energy concept through time. It is solely a history book. It doesn't really go into the physics or the math too in depth beyond what is necessary, of course, for the book to work. But as you can see, very little formulas, a lot of written text, but very interesting book on history of physics and of energy and basically of everything. I think I've learned a lot from this book and basically how things were done back in the past. So yeah, I do highly recommend this. Next we get here Quantum Concepts in Physics by Malcolm Longair, an alternative approach to the understanding of quantum mechanics. Again, quantum mechanics done from a sort of historical perspective. So we see here physics and theoretical physics in 1895, Planck and blackbody radiation, Einstein and quanta. Then part 2, the old quantum theory, the Bohr model and the hydrogen atom, Sommerfeld and Ehrenfest, generalizing the Bohr model, Einstein coefficients, Bohr correspondence principle and the first selection rules, understanding atomic spectra, Bohr's model on the periodic table and the origin of spin, the wave-particle duality, the collapse of the old quantum theory and the seeds of its regeneration, the Heisenberg breakthrough, matrix mechanics, Dirac's quantum mechanics, Schrödinger's and wave mechanics. Then we go to reconciling matrix and wave mechanics, spin and quantum statistics, the interpretation of quantum mechanics, and finally the aftermath. So yeah, a fairly deep book on the history of quantum mechanics and how things were done historically and how exactly people came to understand quantum mechanics. Pretty nice from a mathematical point of view as well. Doesn't solely go into the history, but also does a bit of the math. Doesn't go quite as deep as some other books that I'm going to show you later on. But yeah, still pretty good stuff. It goes into Hamilton-Jacobi equations and everything. So it's a pretty good book. It really goes into this stuff in depth. So yeah. Next we have here, same author, Theoretical Concepts in Physics, Alternative View of Theoretical Reasoning in Physics by Malcolm Longair. And here he goes into pre-quantum stuff. So he starts with Ptolemy to Kepler, Galileo and the Nature of Physical Sciences, Newton and the Law of Gravity, the origin of Maxwell's equations, how to rewrite the history of electromagnetism, approaches to mechanics and dynamics, dimension analysis, chaos and self-organized criticality, basic thermodynamics, then kinetic theory and the origin of statistical mechanics, then blackbody radiation, the quantum stuff, Planck and the spectrum of blackbody radiation, Planck's theory of blackbody radiation, Einstein and the quantization of light, The Triumph of Quantum Mechanics. Then Special Relativity, a study in invariance, an Introduction to General Relativity, the Technology of Cosmology, and finally Cosmology. So again, goes quite a bit into the history and how things were done at the time, how exactly physics was being found out, how exactly it was discovered, and it goes all kinds of very interesting in depth into these things. So yeah, I recommend this book a lot. I think it's a very neatly written book. So yeah. Next we have here Mathematical Topics Between Classical and Quantum Mechanics by Landsman. Yeah. It starts with introductory overview, observable and pure states, quantization, the classical limits. So we see here all kind of use of C-star algebras, quantization, and so on. Groups, bundles, and groupoids, basically reduction and induction, Hilbert C-star module. So a lot of very, very advanced stuff. It goes into the rigor quite immediately. There's actually very little physics in this book. It's mostly math and how the math is being done, how the math is being used to rigorize physics. But physics itself, you don't see too much in here. A lot of math, a lot of function analysis, a lot of differential geometry is all there. Mirror would maybe be interested in this book because it goes quite deep into the mathematics of things. So yeah. Next we have here an atlas of the world history by Christian Guattaloop, the history of humankind in 515 maps. So it sees here we go from the old world to the new world. So you see here the spread of humanity, domesticating plants and animals, North Pole, ancient Egypt, Phoenicians and Carthage. Yeah, it's all ancient maps of the world. Pretty neat book, very beautiful. British India in the 19th century, Indians in America, agrarian France in the 19th century. So yeah, it all goes, yeah, it's all histories of the world. Next we have here a book on the variational principle of mechanics by Lanczos, very famous book that goes in depth into mechanics. So it starts with basic concepts of analytical mechanics, calculus of variations, the principle of virtual work, D'Alembert's principle, the Lagrangian equation of motions, the canonical equation of motion, canonical transformation, the partial differential equation of Hamilton-Jacobi, relativistic mechanics, mechanics of continua, historical survey. So yeah, it's very in-depth in exactly how mechanics how analytical mechanics is being done and exactly what gives rise to it, what exactly we need to do it. So yeah, a very famous book, very good book.